Good morning. Today we are going to take up a few very typical but extremely important questions of the miscellaneous exercise on chapter 6. So, I am going to take up question number 12 first. Question number 12 says, a point on the hypotenuse of a triangle is at a distance A and B from the sides of the triangle. We have to find the minimum length of the hypotenuse. Now, here, so what is given to us is the hypotenuse. Let the hypotenuse of the right angle triangle be AB and let this be C. Now, we are given that a point on the hypotenuse is at a distance of A and B from the two other perpendicular sides. So, let us call this point P. Now, we are required to find the length, or we have to minimize the length L of the hypotenuse AB. Now, clearly L is equal to AP plus BP. Okay. Now, how do we find AP and BP? We only know the distance of this point from the other two sides. So, what we do is, suppose we take this angle as theta. So, because of the parallel lines, this will be this being the corresponding angle will also be theta. Now, in this triangle, this small triangle, we have to find AP, we have to find BP. So, in this small triangle, we know the adjacent side A and the hypotenuse AP. So, we get A over AP equal to cos theta, which gives us AP equal to A sec theta. Similarly, in this triangle, we know the opposite side and we are required to find the hypotenuse. So, the relation between opposite side and the hypotenuse is B upon BP is equal to sin theta, which gives us BP equal to B cosec theta. Now, so we get, it implies that L equal to A sec theta plus B cosec theta. Now, for maxima or minima, we have to differentiate with respect to theta, because theta is the only variable here. So, we get dl by d theta equal to A sec theta tan theta plus derivative of cosec theta is minus cosec theta cot theta. So, I get minus B cosec theta cot theta. Okay. Now, for maxima or minima, we have to put dl by d theta equal to 0, which gives us A sec theta tan theta is equal to B cosec theta cot theta. Now, simplifying, we get A sin theta over cos square theta equal to B cos theta over sin square theta, which gives us sin cube theta over cos cube theta equal to B by A, and this gives us tan cube theta is equal to B by A, and which gives us tan theta equal to B by A whole raised to power 1 by 3, from which we can find the value of theta as tan inverse B by A raised to the power of 1 by 3. Now, at this value, for maxima or minima, we need to differentiate dl by d theta again. So, for maxima or minima, differentiate dl by d theta with respect to theta. So, what do we get? dl by d2l by d theta 2 is equal to, now here if we just see, we have to apply product rule. So, A derivative of sec theta is sec theta tan theta. So, I get sec theta tan square theta because 1 tan theta is already there, plus A sec theta is already there and derivative of tan theta is sec square theta. So, it becomes sec cube theta. Now, minus B derivative of cosec is minus cosec into cot. So, minus of minus becomes plus and I get cosec theta, cot theta is already there. So, it becomes plus into cot square theta. Now, again minus B cosec theta is already there, derivative of cot theta is minus cosec square theta, minus of minus becomes plus and it becomes cube. Now, since all four values are positive, this is greater than 0 when you put tan any value tan theta equal to b by a raised power 1 by 3. It implies we get a minima. Since the second derivative is coming out to be positive, we get this is minima. So, it implies that the length L is minimum when tan theta equal to b by a raised power 1 by 3. Now, to find the minimum length equal to L equal to, now let us put it. Now, we know that L is equal to A sec theta plus B cosec theta, but we know the value of tan theta. So, let us write that in terms of tan. So, A sec theta is under root of 1 plus tan square theta plus B cosec theta is under root of 1 plus cot squared theta. Now, let us simplify it. We get L is equal to A under root of 1 plus, but tan theta is b by a whole raised power 1 by 3. So, I get b by a raised power of 2 by 3 plus b times under root of, now 1 plus cot theta would be 1 upon tan theta, and so I get a by b raised to the power of 2 by 3. Now, let us simplify it. What do we get? A this is a raised power 2 by 3. So, it becomes a raised power 2 by 3 plus b raised power 2 by 3 whole under root upon under root of a raised to the power of 2 by 3 plus same way over here b into under root of b raised power 2 by 3 plus a raised power 2 by 3 whole upon under root of, now this becomes b raised to power of 2 by 3. This gives us L is equal to a times, now under root of a raised power 2 by 3 would be a raised power 1 by 3, and this is a raised power 2 by 3 plus b raised power 2 by 3 plus same way b upon under root of b raised power 2 by 3 would be b raised power 1 by 3 under root of a raised power 2 by 3 plus b raised power 2 by 3. We take under root of a raised to the power of 2 by 3 plus b raised power 2 by 3 common, we are left with a upon a raised power 2 by 1 by 3 is a raised power 2 by 3 plus b upon b raised power 1 by 3 is b raised power 2 by 3, and thus we get minimum length L is equal to a raised power of 2 by 3 plus b raised power 2 by 3 whole raised power 1 plus half, that is 3 by 2, hence proved. Okay. Now, same way we will take up question number 17. Now, let us start with question number 17. Question 17. Now, question 17 says that show that the height of a circular cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r upon root 3, and also find its maximum volume. So, basically we are given a sphere and there is a cylinder which is inscribed in it. Okay. Now we have to maximize the volume of sphere. Okay. Now first of all, what is given to us? Given the sphere of radius r, it implies that r equal to constant. Okay. So what we do is the height and now volume V of cylinder is equal to pi into radius squared into height. Okay. Pi r squared h is the formula for the volume of the cylinder. Now we want to write radius and height in such a manner that we write them in terms of the radius of the sphere and only in terms of one single variable. So let's see. Now let's join this, draw a diameter like this, and this is the center, and join this radius to the end point of the cylinder. Now let's call this O, let's call this, now this is the point A, and let's call this point B, so that the height of the cylinder is AB, and this is, let me call it C. This is the radius r of the sphere. This OA is also, no, OA is not r. Now this is OC is the only thing which is r. Now let's call this r and let the height of the cylinder be small h. Okay. Now height h is equal to AB equal to OA plus OB. Let OA equal to x equal to OB. So it implies that the height h will be equal to x plus x, which is equal to 2x. So this is x and this is also x, and so this becomes 2x. Okay. Now again the radius r of the cylinder is equal to square root of r squared minus x square. So clearly we have managed to write both. Let height of cylinder equal to h and radius equal to small r. Okay. So we have managed to write both small h and small r in terms of x. Therefore volume V of cylinder equal to, V is equal to pi into radius square, that is square root of r squared minus x squared whole square, into h. H is 2 into x. So we get the volume V as 2 pi x into r squared minus x squared, which can be written as 2 pi r squared x minus 2 pi x cube. Let's call it equation number 1. Now we have to, for maxima or minima, we have to find, dV by dx. So what do we get? dV by dx is equal to 2 pi r squared minus 6 pi x square. Okay. Now putting dV by dx equal to 0, we get, now what do we get? 2 pi r squared equal to 6 pi x square, and this gives us, pi gets cancelled, this gets cancelled, we get r squared equal to 3x square, and this gives us x equal to r upon root 3 r upon root 3. Now clearly we would have got plus minus r upon root 3, but we don't take the negative one as x is a distance. So we just take x equal to r upon root 3. Now corresponding to r equal to root 3, we have to find for maxima or minima differentiate dv by dx with respect to x. So we get d2v by dx2 is equal to, this is all constant, so 0, and this is minus 12 by x, which is less than 0 for x equal to r upon root 3, which implies maxima. So this gives us, it implies that that volume of cylinder is maximum at x equal to r upon root 3, that is h equal to 2r over root 3 as was required, that is the height of the cylinder should be 2r upon root 3. Now to find maximum volume equal to, now maximum volume is equal to, the formula for volume is V equal to pi into r squared minus x squared into 2x. Now let's write this. So pi into r squared minus x squared would be, x squared is r squared by 3. So we get r squared by 3 into 2 into x is r upon root 3. So simplifying we get, so maximum volume V equal to, now this becomes 2 pi r over root 3, and this becomes r squared minus this is equal to 2 r squared upon 3, which is equal to 4 pi r cube over 3 root 3, and that is what is required. Okay. In the same manner you can try the rest of the questions of the miscellaneous exercise. Thank you.